this one. Okay. Right. So let's have a look. So so this references is in Bertaline, Technical Graphic Communication, or Medicine and Medicine. That's fine as well. Chapter 10 about the technical drawing. Okay. So for this week, for these 2 hours, we're gonna learn about projection theory. So we have learned about the linear tolerance. We have learned about the geometric tolerance or 3D tolerance and also datum. And then now we're gonna learn about projection theory. Okay, if we have a specimen or we have an object, and how can we describe that in 2 dimension, and then how to make it look like technical drawing. Okay, so we're gonna understand about projection theories and being able to choose and represent the views. The next one is where we would like to have understanding the techniques, the environment, and being able to do free sketching or freehands. I need to check with the general one. Usually there is assignment regarding the freehand sketching, but just maybe wait for another information, even from me or from the coordinators about the assignment. So specifically, you should be able also to sketch by hands, by free hands, and after later on you're gonna sketch it using SolidWorks. Okay, so let's have a look. In projection methods, there are 2 types of projection methods. The first one is the central projection or perspective. Okay, so like the way we see things, we see that mountains very far away look smaller compared to larger. The house may be near to us, for example. Yeah, which it can be a linear perspective or aerial perspective. Okay, in aerial perspective, the object features appear less focused at a distance. Okay, and the second one is parallel projection. In parallel projection, we know that it is our eyes, our side looks like a parallel. It can be oblique, a projection like this, or it can be orthographic. Okay, so in oblique, what is oblique? Oblique means the front side looks like the real real object. Okay, so this is the half depth, and this is the full depth, or if this is the depth varies for a general projection. Okay, in orthographic projection, it divided again with axonomic projection and also multi-view projection. This is the isometric projection. This is the one that we see a lot in technical drawing, where we have this angle A, B, and C would be equal around 120 degrees Celsius, and then also the length of OQ, OR, and OG also quite similar. Okay, this is a dimetric, and this is a trimetric. Okay, and then in the multi-view projection, it can be looks like this, or it can be written as a multi-view projection. This is the one that you're gonna try in SolidWorks later on in your practicum as well, and also what we're gonna learn for today. So here we have the third angle projection, where let's say we have this type of object, and this is the front side, this is the rear side, and this is and this is the top side. Okay, this one there. So when we yeah,
have you started screen sharing, because you're still on the first page?
Oh, really?
Yeah,
Okay, so how about this one? It is still
yeah. Now it makes sense.
okay, right. Okay, so I need to explain again, okay? So we have two types of projection. The first one is the perspective, and the second one is the parallel, okay? So the perspective projection, it looks like when you seeing something, okay? So for example, aerial perspective here, where you have the object, the farther object appear less focused at a distance, okay? And this is a linear perspective. I'm sure, I don't know, when I was maybe secondary school, I used to draw like this, yeah, with the uh, seni budaya, or with the seni rupaya, something like that. And then from a 1 point perspective, 2 point perspective, and 3 point perspective. I think this one is not included in the technical drawing. This one also, we're not gonna include it in the technical drawing. Okay, but for here we have, wait, wait a second. Okay, okay. So this one, the oblique projection, where the oblique projection we have the half depth, yeah, the top one. So the front one looks similar with the object, the real object. This one also the front one looks similar with the object. Okay, and this one it can be half depth, full depth, or depth varies. Okay, and then this one, side of oblique, there is orthographic projection. The first one is called axonomic projection. For example, isometric view. So if your isometric view is quite common in technical drawing, or even in chemical engineering as well. We know that we have isometric diagram. This one, the angle is actually around 120 degrees Celsius, yeah, like this. Or this is a dimetric, where A equal to B but it's not equal to C. And then there's also trimetric, which is all the angle is not in similar one. Okay, and the last one is the orthographic projection. There is a multi-view projection. So if we have this object like this, so we're gonna consider the the front sides, the top sides, and the uh, right right side, yeah, the right sides like that. So here it can be written like this one. Okay, so it's basically this is called third angle projection, when you have the front and then the top and also the right side projection. Okay, by writing this one, by writing by draw this one, we can imagine what is the object looks like. Okay, so here there is a this is the front side, so we can imagine that the front side would be equal to this one. Okay, and then in the right hand side looks like just a block, so there's not just like a block like that, but we know there is something inside here, so there would be like a line here. Okay, and then from the top there is looks like this one. Okay, or it can be in a first angle direction. In first angle in first angle projection, you have the front here, and then you have the top one, and also you have the right hand side, but just a different arrangement. Okay, just the different arrangement, where the top one is actually from uh, the belakang, yeah, over here, yeah, this one here, and then this is the rear side, and also the top one. Okay, so this is the one that we're gonna looking at about the orthographic projection. It can be isometric, or using the what's called the right angle projection, or one angle projection. Okay, so I'm gonna maybe so this is For the first one is called the perspective. Yeah, the perspective, we may not we see this one in a drawing or in maybe architecture or something. Yeah, sometimes we can see this one. And then this one, the parallel parallel projection that we see in a technical drawing. This one, the projection that often used is isometric, and then isometric will be used for the practicum. Okay. And then this is the multi-view projection. We have the third angle projection, like previously. I think this is a bigger picture now. The third angle direction, and then this one is called the first angle projection. Okay, so the third angle projection or first angle projection is going to be used in the practicum. Usually in the real world, how we see, do we use first angle projection or third angle projection, is based on the country and also the standard, and also, for example, if we're gonna use ISO or we're gonna use ASME, it depends. And the students is actually we expected to remember, also understand the symbol for third angle projection and so first angle projection. Okay, so if you look at here, so the third angle projection, you can see it that there is a shape like this. So maybe the shape looks like oops. Okay, let me make it like. Okay, so maybe if we see that there is some tube, yeah, like this is smaller one, and then maybe this is maybe the larger line, like that. Okay, so yeah, something like that. Yeah, so or maybe like this, and then like that. Okay, like a tube, but the tube is not have some direction, some diameter. The lower one is bigger, like this. Okay, so we look at this is the front one. Okay, this is the front one, and then this is the right side. Okay, so it can be projected as this is the front one, like this. There's a smaller diameter and also the larger diameter at the back. Okay, and then we see again at the third angle, the third angle projection, so that way. So it would be like maybe with this sides and then that. Okay, yeah, so this one is called third angle direction. So we see the front, and then after that we see the right hand side. Okay, so the front and the right hand side, and from the top is this gonna be the top. Okay, the conversely, for the first angle projection, we see it first. This is the front. Okay, this is the front, and this is the sides. Yeah, the right hand sides is this one to that way. So we look at from that the other way, and then this is the top one. Okay, like this that is the third angle and also the first angle projection. Okay, so here so we can draw by changing viewpoints. So by changing the position of the same object relative to the line of sight will create different view on the same object. And we really would like to draw where it is very simple, but we have a lot of information from that object. Okay, so first let me explain to you why we use this very simple one, because of course in the real application there is no specimen looks like this, right? But I think we can learn something if we just start with a very simple object like this. Okay, so this one is called orthographic projection. The orthographic projection means we put it like inside like that. Yeah, so here we can see the top really well. So there is a trapezium over here, trapezoid over here, and here there is a block there. Okay, so you can see it there. So this size equal to this one, and this one is also equal to that one. Okay, that is orthographic projection. Okay, and then if it is revolved, that means we slightly tilt the object horizontally like this, yeah, with slightly tilt, then we can try to make again the projection. Okay, again, the aims for us to understand about the technical drawing is actually so we are able to have the dimension that we want. Okay, we are able to find the dimension, this one. Okay, so now so now this is the revolve, and then or this is the tip forward, where it is again tilted again vertically like this. Then we do have the object that that looks like, we can try to imagine the object, but we will have a difficulty here where to make the dimension. Okay, so what we're gonna use? We're gonna use actually the orthographic projection. Yeah, this is the one that we're gonna use, the orthographic projection. Why? Because we want to have a very good dimension, a good dimension of that one. Okay, so let me see again here. So we have 32 participants. Okay, yeah, okay, right. Okay. Okay, so next is actually about the perspective projection. Yeah, the radiating lines of sight produce perspective projection. This one is called this is perspective projection if we're going to use perspective projection, but actually in technical drawing for later on for SolidWorks, we're not going to do this perspective projection. But you have to know the meaning of perspective projection, where the observer is actually in one viewpoint, and then you have a non-parallel of sight radiating from a point like this. So if you do the projection in this plane, okay, in this picture plane, it would be looks like this. Okay, and then so the picture plane doesn't have a similar dimension. Yeah, it can be smaller because of there is a perspective projection. Okay, what we're gonna do is actually the non-parallel, the parallel projection. This is an example of perspective image where the photograph shows the road in perspective, which is how camera capture image, and notice how telephone poles appear shorter and closer and off in some distance. Yeah, this is for a perspective image. We're not going to use this one, of course. We're going to use, we call it parallel projection. Okay, in parallel projection, if we have the real object, let's say this one is the real object, we put a parallel sides like that. Okay, where the observer or the station point would be in infinite viewpoint. So the parallel side would be the line of sight would be not from one point, but it would be in parallel lines. Okay, so here, for example, this is the that would be the center point. Okay, and this would be the sides. This would be the edge of in here, and this would be edge of here. Okay, so when we want to have a projection of this compound or this this object, then it would be looks like this. And then if we measure the dimension, it will be also the same with the object. Okay, so the one that we draw in the picture plane or in the paper on the computer screen would be similar dimension with the real object. Okay, so here we have parallel projection techniques. It can be used for create multi-view or pictorial drawings. Okay, so the one we're gonna use usually isometric. Yeah, this one is isometric. Why is this isometric? Because in isometric, we have, for example, for this particular point, you see this point, this line would be equal to, this angle would be equal to this angle and equal to this angle. So we, in this isometric picture, in isometric drawing, we can see the all of the the type or the how the object looks like. Okay, this one is called oblique. Yeah, oblique is the when we the top surface looks like the real object. Okay, and the other side is become like 3D. Okay, or in this one is called the multi-view. So in a multi-view, you see that you only see in this side. So in the multi-view, you only see from the top side like this. Okay, so it looks like L. Okay, we can't see anything behind it, but we know that there is a curvature like this. There is a half of a circle or half of the cylinder like that. Okay, so there would be something in here, there, and then here there would be a center point, or there would be an actual axis. There would be an axis there, and then this is the symbol for axis for multi-view. So we know that, okay, from the front view, it just looks like L, but we know that inside it there is a surface around here, yeah, which is this one. Okay, that one, and also this is actually like a half round or a half of the cylinder, and then there would be some axis in here. Okay, so this is so this is the orthographic projection, similar to the what's called the multi-view one, yeah, the orthographic projection. So orthographic projection is going to use to create this front multi-view drawing by projecting the details onto the projection plane that is parallel to the view as the object selected as the front, and with those parallel view. Okay, so we have the parallel line of sight like this. Okay, this is the line of sight is perpendicular to the plane or to the projection. So we can imagine there is a plane of projection, which is frontal, and then we try to project all the edge points. So this one projected to here, this one projected here. In here there is a slight line, ya, ada tekukan, ya. There is a slight line over here, so we have to make a straight line as well. Okay, because we have different plane. Okay, if we have different plane, kita punya bidang yang berbeda, ada tekukan, so we need to add this one. Okay, and then here, so again we draw it again. So this one also we draw like that up to this is the edge of the this round over here, so we're gonna put it here and here, and like that. Okay, so there's nothing, and then there is a not, but we know that inside here there is a hole. So because of that, so we're gonna write this you know, those lines, yeah, garis putus-putus, and also we're gonna add the axis, okay, because this is there is a hole here, so we put the axis. Okay, so now parallel to the top view is actually, oops. So yeah, so this one is so this is the object. Okay, so this one is the object. So parallel to that, we're gonna draw maybe I'm gonna change it to blue. Okay, so parallel to this one, this is gonna be the top view, this is gonna be the front view, and then parallel to that, this is gonna be the right side view. Okay, so if I can copy the object like this, maybe let me going back to the end show. Give me 1 second so I can copy the picture. Take a while. Okay, so let me maybe copy this one and then do here. and maybe make it maybe crop. Okay. Okay, wait again. Okay, can you see this? Can you see now in my screen? Hello. Okay. Hello. Can you see my screen?
Yes, Miss, we can see your screen.
Okay. Yeah. Okay, good. Okay, so here you can imagine. So I just look at the green one. Okay, so this is the object. Okay, I'll just so how to make it in a multi view drawing of an object. So the first one, like we said that for the third angle, projection, we know that we have the front over here, and then we have the top, and also here we have the right hand side. Okay, so here we're gonna see it from the front. Okay, so from the front we know that there is a L like that up to here from the projection. Okay, and also a different plane tekukan ya around here. So even it is quite long, but it is inclined karena ini miring ya. So it projected into like this one. Okay, so this is the front view. Okay, with the similar dimension, so this is the front view. So then we're gonna look at the top view from this side, yeah, from the top. What do we have? Do I have something? Okay, as I say, from the top, and from the top we know that here we have a block like that. Okay, from the top view, and then also again a different plane tekukan lagi ya. There's a plane of bidang, so this is the other plane. Okay, up to here. Okay, so and then here there is a one plane around there. So and then here we have the hole. Okay, so this is the all the round over here, and this is gonna be the hole, and the hole has a center point. So from the top view we have a center point. Okay, however, from the top view we don't know how much the height of this one. Okay, we don't know also how much is the height of the hole. Okay, we just see that from the top view there is a hole, and there's a center point, and here there is one plane, and there's the other plane, which is the plane is not in similar or parallel. Okay, the plane it has a different plane, beda bidang, yeah, and also this one have a inclined plane, ada tukikan. Okay, so here, so from the front view we know it, and then the top view we know it, and then to understand to know about the height of this sides, we can see over here. For example, from the top view we know how much is the height over here. Okay, and then one more is the right hand side. So right hand side, we're gonna see it from the right hand side view. For example, from this side, so we're gonna see it from this parallel. Okay, so from this parallel, so we're gonna look at this line, this plane, yeah. Okay, so we're gonna draw it like that. Okay, and then we also have this plane. It's gonna be looks like this, and then from the front there we don't see any hole actually, but we know that from the top view or from the front view we know there is a hole. So we add the axis, you know, the axis, and also the hole inside here, yeah, garis putus. Okay, so even I don't have this object, you actually can imagine this object by combining the front view, the top view, and the right side view. Okay, so here is the principles. Okay, so the observer will be all infinity, and then it is a parallel line of sight. So this looks like how you projected the front view, and then you look at the height should be the same with if you look at from this side as well. Okay, yeah. Then it is also the front view with some width, and this width lebar ini should be the same with this width as well. Okay, so if you look at here, the if you look at here, the width over here, for example, this is going to be the width, would be similar with this width. Okay, so when you have to sketch them in you know, in the multi-view drawing, make sure that you use your ruler, and also you should be able to draw it with that sketch, yeah, with that projection. Okay, looks like this, and this also with the right hand side view. So all the depth should be the same. For example, from this case, so the length of this side, the right hand side, should be similar with also the white in here. Okay, so there you go. So this is the front right side and the top view, and for the third angle projection, you have the front view, and then you have the right side view, and then you have the top view. Okay. And so okay, so this is the how you unfolding the box. Yeah, so if you unfold the box, then you have the front over here, this is the height, and this is the bottom. Okay, so if you open it from that one, this is going to be the top, and this is the L side, and also this is going to be the rear side. Okay, so here, so again, so all the projection lines should be it should have a similar height, width, and also depth. Okay, so I know that in SolidWorks, if you have a 3D object, you can just click those 3 space dimension, and it's gonna be you can automatically draw like this one. Yeah, so I think in SolidWorks you don't need to draw one by one, so they will the software will automatically make it into some multiple parallel projection. Okay, but I think it's very good also for us for sketching, for practice. We have to know how to do it. Okay, so the 3 space dimension or width, height, and depth, and a single view on a multi-view drawing will only reveal 2 of the 3 space dimension. In the 3D CAD system, use X, Y, Z to represent the 3 dimension. Okay, and then when you do the practice, or when you're drawing the projection, you have to maybe make the this one, yeah, the line, the additional lines, garis bantu, so you can try to make this as a proportional as possible. Okay, so alternative view arrangement, it can be the front like this, and this is the top, and this is the right side with the similar which is the related view. So the top view, it can be considered as a center view, but usually the front view is actually related as the central view. Okay, so so we have the US standard. This one is it's called the US standard. So when we have the front, and this is the top, and this is the right direction. Okay, and the second one is the ISO one. Okay, the ISO one, you have the front, and this is the right, and actually the top is just at the bottom there. Okay, and then you have the bottom on the top. Okay, now so we look at here now about the lines. Okay, and then in technical drawing, you're gonna see also a lot of alphabet lines. So this is all the lines from the ASME standard line types used in the technical drawing. So even the thickness of the lines will also represent something. Okay, So here we have dimension line. It is 0.3 millimeters. Okay, this is extension line, and this is the center line. This is called the phantom line. Phantom lines when we have this lengan, yeah. If from that side, if we go move like that, where is the position? So this is the phantom line. And then here garis putus-putus, yeah, it's called here garis patah-patah. It's called short break, right? So just want to see what's inside the equipment. And then this visible line about 0.6 millimeters. I think it's better if we're gonna see this one. Yeah, this is the alphabet of lines. So even the center line is very thin, and then the thickness is 0.3 millimeter. In SolidWorks, it also will be automatically written. So for center line and a very thin line, it is at 0.3 millimeter thin, and also there is garis putus-putusnya, the over here is actually there's some space and the heading for that one. So 1/16, and then 1/8, and then 1/16. This one is for long break thin, yeah, 0.3 millimeter for a very long, for example, long pipeline, and then you break then that one there. And this is a visible line about 0.6 millimeters. The visible lines means all the line that is visible from your eyes, so from the front or from the top or from the sides. This is the hidden line. Okay, it's very thin one, so like this. And even there is the how they write the thin line. So up to here is only 1/8 of inch, and this one is 1/32 of the inch. Okay, and this is the cutting plane. And also there's a phantom line. So all actually this one is the codes. This is symmetry line and cutting plane and so on. Okay, so I think yeah, of course we need to remember all the lines in order to know so what that it really means. Okay, so if you go back here, you can see that here from the outer one is called visible line. Okay, and then this is the cutting plane and so on, the phantom line. Okay, for us who really new to the technical drawing, it is really we need to have some time to try to understand this one. But for our friends in mechanical engineering, this is like day-to-day language, day-to-day language for them. So if you see, for example, this one, a phantom line, okay, so there's actually no object here. It is just the phantom for if this object is moved into that way, so it can be looks like that. Okay, so this is some explanation about that one, the phantom line, to indicate the position if the component move, like a lever can rotate 90 degrees from the horizontal position to the vertical position. A break line if the object is split and it will appear in the components. Okay, and cutting plane line where the object is cut, and then the arrow will show the direction of sight. And then there's some cross section, and then with some name, for example AA, like that. And center line is to show asymmetrical differences. Okay, so maybe you can go back there and then try to again to check the difference. If you see here also the thickness is different. Okay, so for the visible lines the thickness is quite thick, around 0.6 millimeters, but the for example the dash lines or the phantom line, the line is just like half of the thickness of the visible line, only 0.3 millimeter. Okay, so this is some. Okay, so I'll try to explain to you until around 2 o'clock, and after that let us pause and then let's watch a video about the video, yeah, just to get some more explanation. Well, even it is a very old video, but it is it's quite clear compared to some other videos in the YouTube, so we can try to see. So one more. So when we want to draw something, the object, we try to put it in a very natural position. Okay, so for example, this one, it is an unnatural position because of course it's going to be inclined like that if we put this in a natural position. So we put the object on the natural position. Okay, like this. So this is the top view. You can see there inside this object there is a hole. You can see in over here, and this also there is a cylinder and a hole because we know there is a center point. Okay, and then this and that one there has a different plane. Okay, with the base like that. Okay, so this is actually the 3D form, okay, of this one. Okay, so we see that this plane will have different level of plane compared to this one. So if you look at here, slightly bigger over here, yeah, slightly lebih maju, yeah, dikit. Okay, and we know there is a hole over there. Okay, so here, so when we draw it, first we saw it from the top view, okay, and then don't forget to draw the helping line. So this one up to there, this one is up to there. Okay, so you can see the height of those specimen. Okay, this object is going to be the height from the edge to the edge. Okay, and then this is going to be the this is going to be the length. Okay, and for the height, we know the height up to here, so draw again the helping line up to there, and after that we can draw the helping line. Okay, and we know the width, so the width looks like that one from here to here. So this is gonna be the width, and then we can check how much is the width from that one there. Okay, so with those so we need to select minimum number of view needed to completely describe the object, and we can eliminate few that are mirrors of others. Okay, so here we from these three multi-view, we can understand that we can imagine what the this one looks like. Okay, this is from the top view. There is a two line like that, yeah, the previous one, and from the front, from the top view, from here we know that there is bidang, yeah, there is a different plane here to here, so it is the border. Okay, at the border. Okay, and then here from the top view, we know that there is a center point. Okay, there. Okay, like that. Okay, and then this is actually from the sides. Gonna be looks like this. So we're gonna use, this is called the front, the top, and also the right hand side. So we don't need to draw this side. Okay, this one as well, the most descriptive view. Again, we're gonna see again from just the top view. So so the line of sight would be that one. Okay, there's nothing in from the front, but we know here there are two holes. So with two axes, and then this is then with the length of the hole, and there's a bigger hole. Okay, and then from the top one, we can see the hole more clearly with the center point, yeah, from the top view. And then inside this side here, there is a hole as well, and then the axis would be have similar with the center point. Okay, and then from the side, from the rear hand side, we can see it here, and then we can look at over there, and then with some lines, yeah, we only have one lines over there. Okay, so we select the view are most descriptive. Okay, select the view as most descriptive, and also a fewest hidden line as possible. Okay, so don't draw it from the back because all of them is gonna be inside the hidden line. So we can draw them from here, so we can see the the fewest hidden lines. For example, if the right hand side has fewer hidden lines than the left hand side, so we can draw it like this. So don't draw like this. This is from the other sides, but we draw it like this, where we have the more the the visible lines. Okay, and then what happened about the for some shapes? Yeah, for some shapes here, for cone, for truncated cone, this is gonna be the top view, and then this is gonna be the front view. It gonna be looks like this, kerucut terpotong ya, the truncated cone. This is for a partial sphere, setengah bola. This is from the front view, the top view ya. It is the front view, and also this is also from the right side view. Okay, and this is also a prism, a combination of prism and a partial cylinder. You can see it from the front view, the top view, and also the right side view. This is an example of prism and drawing. So we look at from these sides. Okay, we know that there is a block, and also this is a block as well, because this block is actually a cylinder. Then we need to put at the axis. Okay, so for cylinder you have to add an axis there. You can see it from the right hand side view from these sides, and also even from the top view. We only noted that one circle with different plane with the previous one, with the lower one, but because it is a circle, so every circle should have a center point. So this is going to be the center point, where when you look at here, the center point equal to the axis. Okay, and then this one is the hole. Okay, if you have a prism and negative cylinder or a hole, so you can see from the front there's nothing, yeah, but we know that inside there's a hole, so it's going to be looks like this, similar to the previous one, and also from the top one. Okay, so I think this one also would be just some example about how you write. For example, tangent partial cylinder or non-tangent partial cylinder. So here, if no line drawn at the place where the partial cylinder become tangent to other feature, so it is no line indicated tangency. We don't need to add drawing like that. Okay, so because this line is tidak patah ya, the plane is just continuous like this, so we just draw it like this. But if the plane look like this, kelihatan ada garis putus ya, garis putus bidang. So here, if the line indicates no tangency, we can write it just with some visible line over here. Okay, and this is for the machine holes. Okay, but before that, I think maybe some of you also I don't know, to make a refresh, we can maybe pause over here, and then we can let's have a look again first with the video that I have prepared, and then after that we can continue again. Then hopefully with those videos there are two types of explanation from me, and then from the one in the video, so we can have a look on that one. Okay, so feel free, you can also watch in your laptop, but I will also open it in my laptop. So give me 1 second here. Need to close the PPT. Usually it takes few hours there. Okay, so let me close it and open the next. Okay. So look at the week 5. This is a very old video, but they show a very detail on the how they describe. So yeah, see, very very detailed, but it is very good, about 20 minutes. So let's have a look this one. Okay, so let me explain it, and then oops. Okay, it's very old videos. Okay, so okay, so let's have a look about the video. So after that we can continue again. Okay, this basically similar with what I'm explaining, but hopefully we can have more understanding and remember more by watching this video.
Most of the drawings used in manufacturing are multi-view drawings, meaning they represent the shape of an object in 2 or more views. For example, this detailed drawing contains 3 views of the part: the front, top, and right side. This unit will show you how to interpret a multi-view drawing and visualize the part it represents. This is an important skill because it will help you locate the part features you need to perform your job. We'll examine the principal views of the drawing, which establish the basic shape and features of the part. We'll also look at auxiliary views, partial views, and enlarged views, which are sometimes used to clarify the principal views. And we'll explain some drafting conventions, which are accepted methods of simplifying the representation of certain part features. Once you've completed this unit, you'll begin seeing parts from a multi-view perspective, which will make it easier for you to read drawings. To understand multi-views, it's helpful to know how the views are derived. Imagine that this part is enclosed in a transparent box, with its surfaces parallel to the sides of the box. Now suppose that the edges of the part are traced or projected onto the sides of the box. The resulting views are 2-dimensional. They have height and width, but no depth. They're what you would see if you look directly at the sides of the part with your line of sight perpendicular to its surface. When the box is unfolded, you have the 6 principal views of a multi-view drawing: front, top, right side, left side, bottom, and rear. They define the basic shape and features of the part. This method of representing a 3-dimensional object is called orthographic projection. There are 2 types of orthographic projection in use today. Third-angle projections, like this one, are used in the United States and Canada. First-angle projections are used in Europe and Asia. The difference between them lies in the arrangement of the views. For example, the right side view in a third-angle projection appears on the left side in a first-angle projection. The left side view appears on the right, and the top view appears on the bottom. Since this affects how you visualize the part, it's important to know which type of projection you're looking at. Therefore, each one has been assigned a symbol by the International Organization for Standardization, abbreviated ISO. The ISO symbol may or may not appear on a drawing. It's often omitted from drawings done in the United States since they're assumed to be third-angle projections. When the ISO symbol is used, it appears next to or inside the title block. Getting back to the principal views, the number included on the drawing depends on the shape and complexity of the part. Most drawings include 2 or 3 principal views, usually the front, top, and right side. However, a simple part, such as this gasket, requires only one view to define its shape and size, along with a note specifying its thickness. A more complex part, such as this clamp, requires 3 views. The ability to visualize the part from these drawings is an important skill because it enables you to locate features quickly. It's easy once you understand the relationship between the views, as well as some of the visual tricks an orthographic view plays on the untrained eye. As an example, look at the front, top, and right side views of this part. We'll add a pictorial drawing to make it easier to visualize. The front view is the one that best characterizes the overall shape of the part. The other views are aligned with the front so that it's easy to identify related features. For example, the bottom of the notch in the right side view corresponds to this hidden line in the front view. Adjacent views have at least one edge in common. For example, these lines represent the same edge. A surface appears as a plane in one.
Sorry, wait, looks like I'm out of this one. Okay, let's go back. So, okay, maybe just go back a little bit, okay? So, let's continue again. Okay, so let's continue again the video. Sorry for that.
This gasket requires only one view to define its shape and size, along with a note specifying its thickness. A more complex part, such as this clamp, requires 3 views. The ability to visualize the part from these drawings is an important skill because it enables you to locate features quickly. It's easy once you understand the relationship between the views, as well as some of the visual tricks an orthographic view plays on the untrained eye. As an example, look at the front, top, and right side views of this part. We'll add a pictorial drawing to make it easier to visualize. The front view is the one that best characterizes the overall shape of the part. The other views are aligned with the front so that it's easy to identify related features. For example, the bottom of the notch in the right side view corresponds to this hidden line in the front view. Adjacent views have at least one edge in common. For example, these lines represent the same edge. A surface appears as a plane in one view and an edge in another, depending on your line of sight. Let's look at another part. Notice that the curved surface appears flat in the front and right side views, and that the inclined surface appears foreshortened in the top and right side views. Because an orthographic view has only 2 dimensions, height and width, curved and inclined surfaces will appear distorted in some views. That's why it's important to look at all the views in order to understand the true shape and size of a part. With these factors in mind, let's look at one of the model parts included in this training program. These are the front, top, and right side views. The front view best represents the overall shape of the part. The top view reveals its curved surfaces. The hole and counter bore are visible in the top view and hidden in the front and right side views. Their centers are indicated by center lines, which are aligned between the front and top views to establish that these are related features. The cutout is visible in the front view. In the top and right side views, it's represented by hidden lines. By identifying related features in this manner, you can begin to visualize the shape of the part. Let's pause to review. Multi-view drawings are generated by orthographic projection, a drafting technique in which the edges of the part are projected onto the sides of an imaginary glass box. This results in 6 principal views. Most drawings include only 2 or 3 principal views, usually the front, top, and right side. Reading the drawing involves identifying related features from view to view and visualizing the part that is represented. There are 2 types of orthographic projection: third angle and first angle, which differ primarily in the arrangement of views. They are identified on the drawing by an ISO symbol. Most drawings done in the United States are third angle projections. The majority of machine parts can be completely described in 2 or 3 principal views. However, when principal views alone are inadequate, additional views are used to clarify them. They include the auxiliary view, partial view, and enlarged view. For the remainder of this unit, we'll focus on these 3 views, beginning with the auxiliary view. An auxiliary view is used to show the true shape and size of an inclined surface. An inclined surface does not lie parallel to any side of the glass box. As a result, it appears foreshortened in the principal views. This presents a problem if the inclined surface contains holes or other important features which must be dimensioned and shown without distortion. So another side is added to the glass box, parallel to the inclined surface. Projecting the inclined surface onto this side allows us to look directly at the inclined surface and see its true shape and size. Hidden lines and other details are usually omitted, unless they're needed to improve clarity. On the drawing, the auxiliary view is projected from the inclined surface, where it appears as a line, in this case, in the front view. To visualize its relationship to the front view, imagine that the inclined surface is hinged at this edge and can be lifted toward you. Here's another example. Neither the front nor top view accurately represents the shape and size of the inclined surface. The auxiliary view, projected from the edge of the inclined surface in the front view, shows its true shape and size. Again, to visualize its relationship to the front view, imagine that the inclined surface is hinged at this edge and can be lifted toward you. A partial view is sometimes used in place of a complete view to save space or to simplify the drawing. For example, here is a partial view of the top of this part. A break line indicates where the view is broken off. Since the part is symmetrical, a partial view showing half the part is sufficient to describe its shape and size. Partial views are also used to clarify a feature without having to resort to another complete view. For example, in this drawing, it appears as though these edges are at right angles to each other. A partial right side view reveals that they are in fact curved. An enlarged view is used to show a feature in greater detail than is possible in a principal view. For example, this part has 2 grooves which are too small to dimension clearly. So one of the grooves is enlarged and located wherever there is room for it on the drawing. The enlarged view and the circled area it represents are identified by the same letter. An enlarged view has a different scale than the rest of the drawing. In this case, it's 4 times scale, meaning that the groove has been enlarged to 4 times its actual size. Here's another example. In this case, the gear teeth circled in the front view are enlarged to 4 times scale. This allows them to be dimensioned clearly. Let's pause to review. Auxiliary views, partial views, and enlarged views are used to help clarify the principal views. An auxiliary view is used to represent an inclined surface, which would appear foreshortened in a principal view. A partial view is sometimes used for symmetrical parts to save space on the drawing. A break line indicates where the view is broken off. A partial view is also used to clarify a feature without having to resort to a complete view. An enlarged view is used to show a feature in greater detail than is possible in a principal view and to allow room for dimensioning. In drafting, there are some accepted methods of simplifying the representation of certain part features. They're known as conventions. Although they deviate slightly from true orthographic projection, conventions save drafting time and improve the clarity of the drawing. Once you recognize and understand some of these conventions, you'll be able to interpret drawings more easily. The first has to do with line precedence. That is, what happens when two lines on the drawing coincide. For example, in the right side view of this part, the visible line representing this edge lies directly over the hidden line representing this edge. It's not possible to show both lines, so one of them must take precedence or priority over the other. The visible line takes precedence. The rules of line precedence are that a visible line always takes precedence over a hidden line or a center line, and that a hidden line takes precedence over a center line. Here's another example. In the right side view of this part, the visible lines representing these edges take precedence over the hidden lines representing the holes. And the hidden line representing this edge takes precedence over the center line of the hole. The convention of line precedence ensures that the drawing represents the part as clearly as possible. Another drafting convention concerns the use of break lines. A break line indicates where a view is broken off. There are different styles of break lines to represent different types of breaks. A wavy break line is used for a short break. A jagged break line is used for a long break. Another style is used for breaks in rods and tubes. Break lines are also used to indicate that a portion of a long uniform part has been removed. This is sometimes done to save space on the drawing. Phantom lines are another drafting convention. They serve several purposes. They're used to indicate that a part is movable and to define the extent of its movement. They're used to represent the position of an adjacent part and thus help clarify the relationship of components in an assembly. And to save drafting time, phantom lines are used to represent repetitive detail, such as these gear teeth and spring coils. Break lines and phantom lines are part of the alphabet of lines. You'll find a complete alphabet in the general reference section of your application guide. The drafting conventions we've discussed so far, line precedence, break lines, and phantom lines, concern the interpretation of lines. This next drafting convention concerns the altering of a principal view in order to avoid foreshortening certain features. For example, the top view of this part indicates that it has 3 webs and 3 lugs. In the front view, which is drawn according to true orthographic projection, this web and this lug appear foreshortened. As a result, the front view does not accurately represent their shape, nor their relationship to the hub. In cases like this, it is conventional for the front view to be drawn as though the web and lug were rotated into alignment. Although it's not a true orthographic projection, this view more clearly represents the shape of the part. Meanwhile, the top view shows the true relationship between the webs, lugs, and hub. This convention of rotating features into alignment is applied to any part with radial elements, such as webs, lugs, arms, or spokes. Let's review these drafting conventions. Conventions are accepted methods of simplifying the representation of certain part features. Visible lines take precedence over hidden lines and center lines. Hidden lines take precedence over center lines. Break lines are used to indicate where a view has been broken off. The style of the break line reflects the size of the break. Break lines are also used to indicate that a portion of a long, uniform part has been removed to save space on the drawing. Phantom lines are used to represent the alternate position of a moving part, the position of an adjacent part, and repetitive detail. When true orthographic projection of features such as webs, lugs, ribs, and spokes would result in their foreshortening, they are rotated into alignment. The resulting view shows their true shape and proportion. In this unit, you've seen how the principal views of a drawing are derived through orthographic projection, and how to identify related part features from view to view. You've also seen how auxiliary views, partial views, and enlarged views are used to help clarify the principal views. Your ability to interpret these views will help you to visualize a part more easily. It will also help you to understand sectional views, which are covered next in Unit 3.
Alright, so that's all the video for multi-view drawing. It is really informative, and then you can see it with your eyes as well about all the details. Yeah, that quite similar with the one from the slides. Alright, so let me go back to the PowerPoints. Okay, so yeah, so later on you can see it again on the EduNext if you want, if you think you need to check again about the understanding. Okay, now let me try to add the PPT again. Right, so now we know about, okay, yeah, so we know about this, wait, go back there. Okay. So we know about all those lines, about the yeah, the convention, okay, about the right angle projection, and now this is about the representation of machine holes. Okay, it can be hole for bores, or how can we draw it. Okay, so this one is the representation for the hole. Okay, this is called a true hole. So we have this block there, and then the hole is actually go through that one there, and then this is how we write it. This is the diameter, and the diameter, this is the inner the tolerance, yeah, the inner diameter, and the outer the tolerance. So this is the minimum 22.17 millimeter, for example, and this is the maximum of tolerance to 22.23 diameter. Okay, this one is the blind hole. So you have the hole, but it is like a cutoff in this case. This is how you, if we drilled, yeah, if we drilled something. Here, this one is the, for example, this how you write it. This is gonna be the diameter, and this symbol tells you the depth of your the holes. Okay, and then this is for drilled and counterbored hole. This is the larger one, and this is gonna be small one. If it is look at through the object yeah, from the front side. If you can see the hidden lines, this is gonna be the drill diameter, and this is the bore depth. You can see from the symbol, this is gonna be the 19, which is the diameter of the drill. Okay, and then this one, the larger one, is the counter bore diameter, and that's up to here is the depth of the counter bore depth. Yeah, this is they call counter bore, and this is drill. Okay, and then this one again, different types of machine holes, drilled and countersunk hole, how you write it. I think you should know the difference. If you want to see the application, maybe you can look at on websites or on YouTube. Yeah, try to find what are these types of holes. Okay, and also this one is the threaded hole, the hole that has the thread, the screw. Yeah, there's a screw over here. Okay, this is a drilled and countersunk hole, and this is drilled and spot face hole, and this is the threaded hole. Okay, so at least all of these symbols tells you about what happened inside those holes, and also this is from the top view. Okay, and then if we want to have to represent a fillet, rounded corners, we may want to add some lines to add for clarity. So lines are added to parts with fillet and round for clarity. For example, if we have this round, we can't just write it like this one here, but we have to draw the different the line that have different height, yeah, beda bidang, yeah, with the, this one, just to get about the clarity. This one also a type of with different height. So rather than we just put it like that, we also put the line added for the rounds and the fillet, and we added with also the front view. Okay, this one for also for clamp, we add some rounds over here. This types also we add some line over there to just to know that it is a rounded corner and it's representing fillet. Right, okay, and then for the internal and external chamfers, ada tekukan ya, like this. So you can from the top view you see that this is the square. This is a square, and this is the hole, and then the center line. You can see here there is a two different of around like this, and then it is also explained again with the front view, where in the hidden line you can see there is an axis over here, and this is a chamfered hole, lubang yang terpotong ya, the chamfered yang miring, like that, and this is gonna be the hole. Okay, with the external chamfered like this, yang terpotongnya di atas, this one you can see it from the front view like this, and this is also from the top view. Okay, and for some run out, for example like this one, yeah, for if it is tertekuk, yeah, it's like a different plane, you can write a visible line. So run out are used to represent corner with fillets that intersect with cylinders like this. But if it is not sharp like that around, you can put it in like this one. Okay, here also some examples that you can see the rounded one, and then if there you have no line or you have lines. Okay, and then next, like we saw it on the video, there is a partial view. Okay, then the partial view would be created along center line of a brake line like this. It can be on the center line, it can be on the brake line, and it is actually used for symmetrical object like wheel or gears. Okay, so we can have some space with that. This is using the brake line. And then this is because we know that it's going to be symmetrical, this side and also that side is going to be symmetrical. And the way we know from the symmetrical, we can also see it from the right hand side like this. Okay, so here there is a hole inside, and then also there's the axial, and then would be symmetrical like that. Okay, and this one is also the revolution convention, similar example that explained the video, rather than we draw it like as it is and we don't have quite a simple explanation. We can draw it, maybe we can move it with some spaces like that, so we have much clearer projection. Yeah, even this one is the true projection, but the one that's slightly rotated is preferred, so we have a clear explanation of the dimension. Okay, so here, so the sketching. Okay, so the sketching is actually the method for communicating design ideas quickly and early stage documentation in the planning phase, and also before you put it on the software to the SolidWorks, you need to have the sketching. Okay, and then every engineers need to have a sketching skill for any engine, so we can visualize what happened in our brain first with your hands, and then after that you can perfecting that one with your software. Okay, so there are three types of sketching. The freehand with your hand. The second one, mechanical. You're using a ruler, using pencil, and then with some dimension like that, or using a digital, for example using CAD, computer assisted drawing, computer aided drawing, or using SolidWorks, yeah, something like that, all the softwares. Okay, so the design sketching with the freehands is less detail, less structure, and less restriction, and while you have more illustration would be more detail, more structure, and more restriction. Okay, for example, this is the sketching using your hands. If you have a pictorial, this is the pictorial sketch, and this is the multi-view sketch from the top, from the from the front, and also from the top. Okay, I think you should have some assignments regarding the sketching. So just maybe wait for the coordinator or from me to get more assignments about this one. Okay, and then to sketch you have to use you can use a isometric grid like this, or you can use a square grid, or using a perspective isometric grid, a perspective grid, or square grid. Usually square grid or a perspective or isometric is good for us to do sketching. Okay, and then we also need to have some examples, some practice. Even for me also, I still need to do some practices. Yeah. So there is, for example, this is, so when we draw, it should be like that. Drawing nggak boleh miring ya, but yeah, would be like that, for example. So we can't use that one. So this is a big no-no. Don't also try to like that. This also is a big no-no. So try it in your pen how to make really a straight line. Yeah. For my case, because I'm using this Wacom, yeah, that this one I think it's not really good, but at least you can try it with your pencil at home now. Try to find those straight line. Okay, so this with the Wacom, it looks like not really good. Okay, I'm just gonna put it with the eraser. Okay. Okay, let's go back there. So first, so here, for example, to make sketches, you have to make some stages, auxiliary and some auxiliary lines. For example, you have you want to draw these sides. You may want to let me try to check here. For example, you check the height and also the width. Yeah, this one is also not very good, yeah, because of this. I think, yeah, I think you can try this is using the using the pens doesn't really good. See, like that. And after that, once you know the step, and then you can find the next sketching steps, yeah, like that. And then you can use pencil first, and then after that you make the hole like that using this square. So once you get the square, you can draw your hole using a pen, this also, and then again start to follow up this JSON one. I think I can do that in the class using chalk, yeah, but this one using Wacom is not really good, so I let you try it by yourself, yeah, to do sketching. And then after that, when you have the auxiliary lines, you can close your auxiliary lines. Okay, so try it by yourself in your house now, and then in your spare time, try to make a sketch using those auxiliary lines, and this auxiliary lines like in using a pencil. And after that, once you have your own drawing, and then you can delete, you can just erase those auxiliary lines. Okay, so this one is a very old monitor, yeah, but still very old, like for with 3 and 4, 3:4. Okay, so this one is the sketching of the monitor, very old one. This one is poorly proportioned for a very old monitor, but now we know that this monitor is actually this one, yeah, that we have. Okay, so for the sketch, there are some types. The first one is the multi-view ones, and then this is the axonometric or the isometric, yeah, that we looking at. So we would like to say this one, and this is the perspective, and this is the oblique. So in the oblique, you have the front view similar to the front side in your multi-view. But in axonometric or isometric, you have these points, and then this actually quite similar with 120 degrees Celsius. Okay, so this is the sketch that illustrates the 3 dimension of an object in one parallel using projection. So the length would be about 30 degrees Celsius, 30 degree in each side, yeah. So you can make start from making lines, and then in this one point, and making 30 over here, 30 over here, up there, and then this gonna be your vertical one, and then start doing the sketching, okay, to get this one there. Okay, so here, so this is how the steps to structuring the isometric sketch. First, you make these points, yeah, using isometric axis. If you can find isometric paper on websites, yeah, PDF on Google's, and then you can get that, and then also print it. That also can be okay. So you can print one of the isometric sketch, but if not, make a point there, and then with your butuh derajat in Indonesia, you can to find 30 degree over here, 30 degree over here, and then this is the vertical one. Okay, and then you can just edit the width, and also the depth, and also the height if it's able, in order to make this block. Okay, and then try to check about your box over here. Okay, so this is actually, we know that this gonna be the shape. Okay, so this gonna be the shape, so we know that there's to be up to here. Okay, so this is gonna be those shapes, and then after that, check again around the sides. Okay, around the side there is a cut over here, so maybe we want to add like that. Okay, so would be like that one, and then again there is a notch over here, a cut over here, so you can add that one. Okay, so step by step, try it by yourself to get the structuring some isometric sketch. I'm really sure one of the exam question would be about asking you how to do a freehand sketching about the isometric drawing. Okay, and then how to get the isometric representation for the circles. This is the good way, this is the correct way. So if this is the way how to do it, so don't do it like this. So this one is incorrect, but this is gonna be the horizontal one. So it's quite similar with the one that we see within your eyes. Okay, so this one also the multi-view sketch. You can see it if this is from the width, depth, and the height. So what you see from the front, you see from the parallel line of sight, you can see there is a block over here with this width and then this thickness. Okay, and then you can see over here also perpendicular to the observer at infinite position. You see these points there, and that would be a hole. Okay, so that is from the front view. With that one, you can also try to sketch what is the right hand side view and also from the top side. Okay, so back again from the sixth principle, you should be able to try it by yourself if you have this pictorial drawing, how to draw it from the front side, right side, and also the top one. Usually these three drawing, it should be enough for us to try to imagine what the drawing looks like. Okay, and also don't forget about the lines. There are visible lines, it's quite thick, yeah, and these are the hidden lines, only 0.3 millimeters, so half of the thickness. So if you use a pen, then if you use pencil, don't use the same distance, yeah, don't the same thickness. Maybe you can use I don't know, pencil mechanical pencil or something to try to find the thickness. Okay, because thickness is very good. This is center line, so it's like long line and then a short line and a long line, so that it typical of center line. And then this is dimension. You have the arrow just inside there, and this is the phantom line, has two small short lines and then along with the long line. This one is the cutting plane. Okay, this is the cutting plane and construct line, and this is the section line. So section line is actually when you have this block here and then you cut into two, and then this is gonna be the section one. So this is actually the sections ones. Okay, so again, this one also the convention of making hidden lines, like the previous one we saw in the video. So the visible lines will take a priority compared to the hidden lines, and the hidden lines will take priority compared to the axis here, to the center line. Okay, so you can try to have a look here if you have this quite complex here. So how to draw this one. Alright, so okay, so this is the line hierarchy that we know that visible line takes precedence over all other lines, and the hidden lines and cutting plane lines take precedence over the center line. So center line is actually the last one. Yeah? It doesn't have precedence because center line is actually imaginary line, yeah, for that one. Okay, so we can see it here from this is from the top, yeah. So from the top view, here you have those visible lines. There you have the visible lines there. So the hidden lines are actually, so the visible lines take precedence under the hidden lines. We do have hidden lines over here, hidden lines of the whole, but it is precedent. But we know that we have a center line over here. We have the axis here, so it should be there something inside, and it would be there's a hole. In this case, we have the center line, but also we also have hidden lines. So hidden lines will be over the center line. So this tells you there is a hole, and of course hole will have a center line, but it is actually override with the hidden line. Okay. So, and then here, all the hidden lines will be visible, or the center line would be visible on the right hand side view. Okay, so you can see it, all of them on the right hand side. Okay, so here also a small dashes across at the center. So this is about the center line. This one, the center line should be a little bit more than the object, yeah, about 8 millimeters or 3/8 inches around this one. And then for the center line as well, this tells you that you have a parallel center line over here, okay, like that. That would be also quite similar. All right, so looks like I don't know for the assignment. So I haven't got the explaining about the assignment. Just maybe wait for some more details. I think this one is actually from last year's assignment, so I think it should be the same. But there would be some assignments about freehand sketching. Okay, so anyway, I think that's all for today. So at least it's all about again remembering, try to understand about all those lines and all the convention, and then now you also need to try to do some sketching, okay, with pencil, and after that with the pen, and then you can erase them with the pencil. All right, I think that's for today. But before that, maybe do you have any questions? Okay, I think hopefully it should be a little bit clear. But if not, then you can use your another 2 hours. Yeah, 2 credits means 2 hours in the class, 2 hours you study it by yourself, and 2 hours of practicum. Okay, so try to check again, and then maybe it's gonna be good if you have an example to draw some of these, yeah, some of the principal view, and then try to do sketching. And after that, once you know how to sketch freehand, and then later on in the practicum you can sketch this one like straight away from SolidWorks. All right, okay, so if there's no question, I need to stop this class, and thank you very much for your attention, and I'll see you again next week.
Thank you, Miss.
Thank you, Miss.
Thank you, Miss. See you next